Hey, it's Mr. Kaczynski here, wrapping up another section of skills in IXL's Algebra 1, section double C. Today it's describing linear and exponential growth and decay. Okay, so we've done a couple over unit intervals. This is a little bit different because it's not a unit interval. We're asked how it changes over this interval of 3 units, okay, from 1 to 4, from t equals 1 to t equals 4. How does it change over that interval? So what's this increase right here? Maybe I should do that in a different color. What's this increase? And that's from 1 to 4 as well. So that's an increase of 3. All right, what about over the interval? This one, different function here, over the interval from 1 to 3. So here's our interval, change of 2, by the way, from 1 to 3. Right there, that interval of 2. What happens? Well, we go up from 4 to 10, and 10 minus 4 is 6, so that's an increase by 6. Some might notice too that this line has a slope of 3. So if we do 3 times this 2, you'd get 6. All right, so then we get into exponential functions and their change over an interval. Again, our interval here, that's the first thing I'm going to look at, is an interval of 2. All right, so we could actually figure this out. Let's do that. Let's do f at 4 equals 3 to the 4th, which is 81. And then we'll do f at 6, which is 3 to the 6th, which is 729. So what happened here? It definitely didn't decrease. Okay, did it increase by a factor of 6? 81 times 6 is 486, not 729, so it didn't do that. Did it increase by a factor of 9? 81 times 9 is 729. Yeah, that's what happened. Okay, but there's an easier way for us to figure this out. We could have just taken this 2 right here and this 3 right here and done 3 to the 2nd power, and that would have given us our factor of 9. So that's the trick we're going to use from here on out. But that doesn't work with linear. This is a linear relationship. But we'll look at the interval here. It's an interval of 3. But we can still do this, though. We can do 2 times 3. And that'll give us 6. So since it's linear, it increases by 6, not by a factor of 6, just by 6. So it used to be 2 times 1, which is 2, and now it's 2 times 4, which is 8. The difference from 2 to 8 is 6. All right, so we have this interval. It's an increase of 3. We've got this base, which is 5. If we just do 5 to the power of 3, that's our factor, which in this case is not even broken down into 125. It just says increases by a factor of 5 to the 3rd, and that's it. We're done. All right, again, I'm going to notice my interval here. It's an increase in 3 in the x values. This is linear, okay, so it's just going to be 1.05 times that 3, which would be 3.15, but even then it's not broken down for it. Like, it's not simplified. It just increases by 1.05 times 3. Couple more. What about this one? This one's a little bit funky here in that, okay, here's our increase. X increases by 2. Here's our base, 1.2. Let's do 1.2 to the power of 2. What does that equal? That equals 1.44. Okay, or 144%. We could look at it like that. Okay, and that's indicated right here, an increase of 44%. And this one's kind of like that, but it's decreasing because the base is less than 1. So our interval is an increase of 2 of x, and then our base here is 0.9. So if I do 0.9 squared, that gives me 0.81, which is like 1 minus 0.19. Okay, that's a decrease of 19%. We're losing 19%. So those at the end might get a little bit tricky for you, but that's describing linear and exponential growth and decay over intervals.